Okay, so these are the notes for, hold on, let me get this adjusted for me. 5-3, medians and altitudes. Okay. Alright, I'm going to start off by giving you a chart of all 4 of our major segments, not including the mid-segment. I know we've already done the foldable, but here's just another way to demonstrate the 4 vocabulary words to help you try to memorize them before the quiz. The perpendicular bisector, the angle bisector, the median, and the altitude. Okay? So we're going to break down their definitions. Because when you get to the quiz and you are asked to identify these segments, you need to ask yourself, does it go through a vertex? Does it go through a midpoint? Is it perpendicular? Okay? Because that'll help you narrow down the definition. So we're going to do vertex. Does the perpendicular bisector go through the vertex? If you're not sure, go back and look at your flip chart. It does not. The angle bisector, yes it does. Median, yes it does go through a vertex. Altitude, yes it does go through a vertex. Okay. Midpoint, which one of these goes through a midpoint? Does a perpendicular bisector? Yes. Does an angle bisector? No, not necessarily. Does a median? Yes, it's part of the definition. The median has to go through a vertex and a midpoint. Altitude does not necessarily go through a midpoint. Okay. Is it perpendicular to something? Well, we got matching symbols here, so I hope we have a check mark there. Angle bisector is not necessarily perpendicular. A median is not necessarily perpendicular, but an altitude is. And if you go back look at their definitions, these are the 2 that talk about being perpendicular. And then again, we have the point of concurrencies. Okay, so if you want to remember these, this is circumcenter. This is incenter, centroid, and orthocenter. Okay, so this is just kind of a breakdown of the definitions. Perpendicular bisector goes through a midpoint and is perpendicular. Angle bisector goes through the vertex. The only thing it does is bisect the angle. Median goes through a vertex and a midpoint. Altitude goes through the vertex and is perpendicular. Okay? Alright. Most of the questions in this section is going to be just pure vocabulary. They're going to give you a picture and they're going to ask you what kind of segment it is. Okay, so you're not going to understand it at first, but if you'll have this or your flip chart in front of you as you're doing the problems, you should be able to start memorizing them a little easier. But it's really important to have these memorized. We talked about how important vocabulary is in class. Okay, there are a couple of difficult questions in this section. Like I said, the majority is just going to be straight vocab, so it's not a hard section. But I'm going to give you a couple of examples of some of the harder ones you'll see. So don't think all of the homework is this hard. I'm just giving you examples of the hard ones. Okay, let's talk about circumscribing a circle. You're going to have some silly questions that ask you to find the center of a circle that you can circumscribe about a triangle. Anytime you see the word circumscribe, think circumcenter. Okay, that's all they're wanting you to find. They're going to come up with some really fancy ways to ask you to find the circumcenter. Okay, and they're going to use the word circumscribed. Circumscribed, I'll show you what circumscribed means. Okay. So, I don't know why I just drew that. Because the next example is going to have a coordinate grid, but not this one. Let me just give you a triangle. Okay, if I do a triangle, and I draw all of the, which one is for circumcenter? Which segments am I going to be drawing? I'm going to be drawing the perpendicular bisectors. So there's a midpoint, and I'm just going to eyeball it, perpendicular. There's a midpoint, perpendicular. There's a midpoint, perpendicular. So this would be my circumscribed circumcenter. Okay. What a circumcenter does is not only is it the point of concurrency, but it also happens to be, like the question will say, the center of the circle that's circumscribed about the triangle. All that means is that this is the center of a circle, that if I pick these 3 points and I draw a circle through the vertices, then this point happens to be the center of that circle. So, like I said, that's a lot of vocabulary, and I will tell you most students never really understand that question, but I want you to be prepared if you ever see it someday on a test. So, circumscribe, circumcenter. All you have to do is remember that circumcenter goes with the perpendicular bisectors. So what will this look like as an example? Again, this is why I drew that. Alright, so let's say I give you 3 coordinate points. 2, 3, 4, 3, and 4, 5. If I plot those, 2, 3, 4, 3, and 4, 5. And if I ask you to find the center of the circle that is circumscribed about the triangle. Again, that is test maker verbiage. It is not my verbiage, but you will see something like this someday on a test. So, center of the circle that's circumscribed about the circle. I'm going to focus in on this word. Circumscribed reminds me of circumcenter, and circumcenter tells me to draw perpendicular bisectors. So, perpendicular bisector goes to the midpoint. Now, the one nice thing that the book will do, and I'm sure most tests will do, is it's going to make you so that you should be able to draw these very, very easily. Notice this is a perfectly horizontal line. This is at 2, this is at 4, so my midpoint is going to be 3. And my perpendicular line is going to be vertical, right? Alright, this is at 3, and this is at 5, so my midpoint is at 4, and it's perfectly horizontal. So this point should be 3, 4. And that is your answer. That's all you're doing, is drawing the perpendicular bisector here, drawing the perpendicular bisector here. Where they intersect is going to be the center of the circle that's circumscribed about this triangle. Like I said, this is one of the harder questions on the homework. The rest of them are much easier. You're just doing vocabulary. But circumscribe, circumcenter, find the perpendicular bisector. Okay? There's only one question like this, or 2. I think one that gives you the picture, one that doesn't, and I'll be around to help you if you don't understand it. Alright, next. Okay. Alright, if you ever see the word inscribed, same kind of concept. Inscribed reminds you of in-center. Go back to the chart and find out which segments make in-center. Well, if you go back, it is your angle bisectors. Okay, so if I draw my angle bisectors here, here, and there, that gives me my in-center. And the in-center happens to be the center of the circle, that if I try to fit a circle exactly in the inside of a triangle, in-center, think inside, then the center of that circle is actually going to be where the in-center is. All of this is just kind of coincidence. It's just the properties that it has. It's always going to be true, and it's just kind of a coincidence that it happens. Okay? Now, you won't have a coordinate grid question on this because you can't really draw angle bisectors on a coordinate grid. But your question on this one will look like is...
Attention students, there was a bus change. Bus 429 is bus 497. 429 is 497.
What you will notice about the in-center, another thing that you need to notice about the in-center, and we're actually going to add this to our foldable, is that it is equidistant to the sides of the triangle. Okay? Equidistant mean the same distance. That means the distance here and the distance there and the distance here is all going to be the same. All three sides of the triangle is the same distance away from the center. So, you might have some kind of word problem. I'm not going to give you an example because we're already at 10 minutes. There's only one of these in the homework, and if, like I said, if you get stumped, go back to this. If it doesn't make sense, get me in class and I'll explain it to your group. But you might have a question about something, like some kind of word problem that says, where would you put the water fountain so that it's equidistant to the sides of the three buildings, or something like that. So you're just going to have some kind of application problem like that. But this is what you need to know for in-center, is that it's equidistant from the sides. Okay? Let's go actually back to the other page. Circumcenter is actually equidistant to the vertexes, which that was kind of explained by going through the circle. If this is the center of the circle and it's going through the vertexes, then obviously it's equidistant to the vertexes. But again, we're going to add this to our foldable. Alright, now, you wrote down a theorem about mid-segment, or medians. The median theorem. Okay? Go back and read it again. It talks about the median being 2/3, or a ratio of 1 to 2, right? So if I do midpoint, 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 and I draw all of my medians, this gives me my centroid. This is a ratio of 1 to 2. So that means it can be divided into 3 equal sections, right? Okay. So here's an example of the median theorem. Okay. If this is B, G, A, B, C, and this is D, I'm going to tell you that DE equals 6. Now I'm going to ask you to find BE. Now in our flip chart, in our foldable, I gave you 3 different equations you can use. Okay, depending on what information you're given is going to determine which one you need to use. This one gave you DE. Okay, in the theorem, I told you that BD is equal to 2DE. I might have used different letters, but this is the same concept that I gave you in your flip chart. Or I told you that DE is going to equal 1/3 of BE. So what this is saying is that the smaller section is 1/3 of the total, right? This is saying that if I take the bigger section, that's going to equal twice as much as the smaller section. That's that 1 to 2 ratio right here. And then I also told you that DB, which is the bigger section, is going to be 2/3 of the total. We are told DE, okay? And we are asked to find the total. So, this is the one I'm going to use, okay? DE is 6, is equal to 1/3 of BE. To get rid of the 1/3, you just flip and multiply. So 3 over 1, 3 over 1. So BE is equal to 18. Okay. Another example of the same picture. Okay. I'm sorry, that's supposed to be an F. If AF equals 28, find AD. AF is the total length. Remember, these two are the ones that dealt with the total length.
Allie said Cruz, report to the front office. Allie said Cruz, please report to the front office.
Alright, these are the two ones that dealt with the entire length. So I know I'm going to be using one of these. Now, is AD the bigger one or the smaller one? Well, to me it looks like the bigger one, right? One of them is twice as big as the other. The one that comes from the vertex is always going to be twice as big. Okay? So we're dealing with the bigger one. So that's going to be the one that's 2/3. Okay? So that means the length I'm looking for, which is AD, is going to be 2/3 of the total, AS. Okay, so I'm looking for AD is equal to 2/3 of 28. Which is equal to, I did not get a calculator out, 48 divided by 3. Okay? Alright, we're done with the notes, but let me just talk to you guys for a second. I know, especially in my regular ed class, not really so much in the pre-AP, but in my regular ed class, about a third of you have been really frustrated with the flipped classroom. Some of you are giving up on me, which I really don't want that to happen. I've told you from the get-go that if you're doing what I ask you to do and you are trying hard in my class, I am not going to fail you. I will do whatever I have to make you do to be successful. Okay? But I think the misconception is that you're expecting to watch these videos and completely understand things. That's not going to happen. It wouldn't happen if I was giving you these notes in class. You wouldn't understand everything. Okay? And I think that's where people are getting frustrated, is they're expecting to understand this all at home and then come to class and be able to do the homework. That's not the idea of the flipped classroom. The flipped classroom is to kind of write stuff down, sort of get an understanding of it, maybe not fully, not expected to get it fully, okay? Come to class the next day, I review it with you, and I answer your questions. Like I said, the biggest problem I'm having, and mostly in my regular ed class, is that you're not watching the video, and then you're not asking questions either. So I can't help you if you're not going to watch the video and ask the questions. But if you can watch the video and write down the notes, even if you're completely lost, it's okay if you're completely lost. Okay? You have it written down, and at least you have an idea of what you're going to be learning the next day. Then you come to class, I answer your group's questions, and then you start on the homework, and you learn kind of as you go. After I've answered all your questions and you have a basic idea of what's going on in the notes, then you work a problem. If you don't understand it, I fix that understanding, and then you work another problem. And you're not expected to understand this all until the end of the class. By the end of the class, after you've gone through all of the problems, then you're supposed to understand it. Okay? And I think a lot of people are just shutting down on me, and you're not watching the videos because you say you don't understand the videos, which, again, like I said, you're not really expected to understand them fully at home by yourself. So you're not watching them, and then you're coming to class and saying, well, I'm just not going to do the work because I didn't watch the video. Guys, I love teaching. I love kids. I want to help you, but you have to let me help you. And again, this message isn't to everybody. I know it's a smaller group than you believe there is, but I need that group to be even smaller. I need you all on board. Even if it's just a handful of kids, I need you all on board with this because it's such an amazing opportunity to get true learning and true mastery of the subject. But anyway, I just wanted to let you guys know that, so that as you're doing these, if you're a little frustrated and not understanding it, that's okay. It's okay. I'm not expecting you to understand this completely by yourself. Okay, that's not the idea of the flipped classroom. So the idea of the flipped classroom is to get the notes part out of the way, and then come to class and get that relearning and get the learning in class. I'm still going to be teaching you in class. The problem is I have too many people that aren't letting me teach them in class. They're quitting. Okay? Don't quit. I'm here to help you. All right? Bye.